Assalamu alaikum. Now I'm going to solve another decimation problem. Let's see the question. Draw a circuit diagram. Draw a circuit diagram of shunt generator. Terminal voltage of a shunt generator is 250 volt. Load resistance 12.5 ohm. Shunt field resistance 250 ohm. And armature resistance is 0.25 ohm. Find out the armature current and generated EMF. So let's try the first portion. Draw a circuit diagram of a shunt generator. Let's draw. As you can see, the DC shunt generator, the field winding will be at parallel position with respect to the armature coil. So the terminal voltage is 250 volt and the terminal resistance, the load resistance is 12.5 ohm. So we can connect a load which resistance is 12.5 ohm and shunt field resistance 250 ohm. 250 ohm, this is the shunt field resistance, and the armature resistance is 0.25 ohm. So here is the armature coil, so armature resistance will be inside of the armature and the value of the armature resistance is 0.25 ohm. Okay, find out the armature current and generated EMF. So let's try to set the equation of generated EMF. According to the KVL, we can write EG equal, that means generated EMF EG equal terminal voltage plus armature current and with multiplying armature resistance. Okay, now we know the terminal voltage 250 volt plus we have to find out the armature current and we have the armature resistance. Okay, what is the value of armature resistance? The armature resistance value is 0.25 ohm. Now let's find out the armature current. Now we can see the armature current is coming from the armature coil and it divided in two ways. One of them is load current or terminal current and another is shunt current. So according to the law of KCL or Kirchhoff's current law, we can write IL plus ISH. Okay, so IL equal, here we have to find out the IL or load current. We have voltage, we have load resistance, so according to the Ohm's law we can find out voltage divided by resistance. So terminal voltage is 250 volt and resistance is 12.5 ohm. So we can write the load current 20 ampere. So load current is 20 ampere plus we have to find out the shunt current. So shunt current ISH equal 250 volt. Let's see, the terminal voltage 250 is parallel to the shunt resistance or shunt field, so we can say the terminal voltage is also 250 volt. So voltage divided by resistance, the shunt voltage is 250 and shunt resistance is 250, so the current is 1 ampere. Okay, so here is the current. Okay, so this is 21 ampere, so the armature current is 21 ampere. Now terminal voltage 250. Now get back to the EG. IA equal 21 into 0.25. Let's calculate the equation. We can find 250 plus 21 into 0.25 So the multiplication of 21 and 0.25 is 5.25. Now the total voltage, that means total EG, generated EMF, is 230.25 volt. So this is the solution. Okay, thanks for watching the video. You are most welcome.